Hello, this is Quisaria. Welcome to the channel where we explore the most mind-bending mysteries of the cosmos. Today we'll talk about a question that haunts scientists and philosophers. What lies beyond the edge of the universe? Imagine, you're flying through space faster than light, past galaxies, quasars, black holes. And suddenly, you reach the edge. What's next? A wall? Emptiness? Or something so incredible that our minds cannot conceive it? The first problem: the universe has no edge in the usual sense. Modern cosmology tells us that the universe has no boundary that could be reached. Why? Because space itself is expanding. It's not objects flying apart in a void. Space itself is stretching like the surface of an inflating balloon. If the universe is infinite, then it simply has no edge. If it's finite, then it may be closed upon itself, like the surface of a sphere. Walk in any direction long enough, and you'll return to your starting point. But what about the observable universe? The observable universe is a different matter. This is the part of the cosmos whose light has had time to reach us in the 13.8 billion years since the Big Bang. Its radius is about 46.5 billion light years due to the expansion of space. Beyond this event horizon lie regions whose light hasn't yet reached us. There may be galaxies, stars, planets, entire universes we'll never know about because the expansion of space carries them away faster than the speed of light. Theories about what might be beyond the edge. More of the same, the simplest hypothesis. Beyond the horizon, space simply continues, just like ours: galaxies, dark matter, stars. Multiverse. Our universe might be one bubble in an infinite foam of universes, each with its own laws of physics, constants, and history. Quantum boundary. Some theories suggest that at a certain scale, space-time becomes grainy, quantum. Perhaps beyond the edge of the observable universe, something fundamentally different begins. Nothingness, a philosophical concept of absolute emptiness. Not cosmic vacuum, but the absence of space and time itself. Why can't we know for sure? The problem is that we physically cannot look beyond the cosmological horizon. The expansion of the universe means that distant regions are receding from us at speeds exceeding the speed of light. Information from there will never reach us. This is a fundamental limitation, not technological, but of the laws of nature. What does physics say about the edge of space-time? Einstein's general theory of relativity describes the universe as four-dimensional space-time that curves under the influence of matter and energy. In this model, the question, "What's beyond the edge?" loses meaning because the edge simply doesn't exist. Imagine an ant on the surface of an orange. It can crawl infinitely, never reaching an edge, although the orange's surface is finite. So too our universe may be closed in dimensions we don't perceive. Dark energy, the key to the universe's future edge. But here's what's truly captivating. Dark energy, a mysterious force comprising about 68% of all the universe's content, is accelerating the expansion of space. If this expansion continues forever in the distant future, in trillions of years, we'll find ourselves in a completely lonely universe. All distant galaxies will disappear beyond the event horizon. Future observers will see only their own galaxy, surrounded by absolute darkness. In a sense, the edge of the observable universe will contract closer and closer to us. The Big Rip scenario. There's an even more extreme theory. If dark energy intensifies, Expansion could become so rapid that it will tear apart not only galaxies and stars, but atoms and even the very fabric of space-time itself. This is called the Big Rip. At the moment of such a rip, the universe will literally fly apart into quantum fragments. What will remain beyond the edge after that? Perhaps new space-time, a new cosmos being born from chaos. The Fermi paradox and the edges of the universe. Here's an interesting thought. If the universe is truly infinite, then somewhere out there, beyond our horizon, all possible combinations of matter must exist, including exact copies of Earth, copies of yourselves, civilizations of unimaginable development. Infinity means that everything that can exist exists an infinite number of times. But we'll never meet these duplicates because of the insurmountable barrier of expanding space. Could our universe be a simulation? Some physicists, including Nick Bostrom, suggest we might be living in a computer simulation. If so, then the edge of the universe is simply the boundary of the simulator's computational power. Beyond it, nothing, because the simulation doesn't calculate what we cannot observe. Sounds like science fiction? Perhaps, but we have no way to disprove it yet. Philosophical perspective. Ancient philosophers asked, what came before time? Today we ask, what lies beyond space? Perhaps these questions have no answer, not because we're not smart enough, but because the questions themselves are built on false assumptions about the nature of reality. As philosopher Ludwig Wittgenstein said, "Whereof one cannot speak, thereof one must be silent." But scientists don't like to remain silent. Inflationary theory and eternal inflation. In the 1980s, physicist Alan Guth proposed a theory of cosmic inflation. The idea that in the first fractions of a second after the Big Bang, the universe expanded exponentially fast, increasing in size by 10 to the 26th power in a negligible fraction of a second. But here's what's truly insane. According to the theory of eternal inflation, this process never stops completely. In most of space, inflation continues eternally, generating an infinite number of pocket universes, bubbles like ours. Our universe is just one such bubble where inflation stopped and galaxies appeared. But beyond its boundaries, beyond that very edge, inflation rages, creating trillions of new universes every second. Each of these universes may have different physical laws, different values of fundamental constants. In one, protons are heavier. In another, light moves slower. In a third, there are no atoms at all. Universe collisions. And here's the scariest part. These bubble universes can collide with each other. In 2015, astronomers discovered a strange cold spot in the cosmic microwave background, an area significantly colder than the surrounding space. Some scientists suggested this might be a scar from a collision of our universe with another in the distant past. Imagine, two universes touched, and we see the trace of this cosmic accident. If this is true, then beyond the edge might not be emptiness, but other universes literally next to us, but in other dimensions of space. Black holes and white holes. Portals beyond the edge? There's another crazy idea. What if every black hole in our universe is an entrance to a new universe? Inside a black hole, beyond the event horizon, the laws of physics break down. The singularity is a point of infinite density where space and time swap places. Some theorists suggest this singularity might be the Big Bang for another universe. On the other hand, theoretical white holes exist, the opposite of black holes from which matter and energy erupt outward. Perhaps our Big Bang was a white hole, and our universe was born inside a black hole of another parent universe. Universes within universes, like matryoshka dolls. Beyond the edge of each, a new reality. Quantum foam and Planck length. Let's descend to the most fundamental level. At the scale of Planck length, that's 10 to the minus 35th power meters, space-time ceases to be smooth. It becomes foamy, seething with quantum fluctuations. At this scale, virtual particles constantly arise and disappear. Tiny black holes flicker in and out of existence, and the very concept of place loses meaning. Perhaps at the very edge of the universe, at the boundary of existence, space breaks down into this quantum foam. Beyond the edge is neither nothing nor something, but a superposition of all possibilities, a quantum state where reality hasn't yet been determined. The holographic principle, universe as projection. Now prepare for a real mind blow. The holographic principle, proposed by theoretical physicists, states that all information about the three-dimensional universe can be encoded on its two-dimensional boundary, like a hologram. This means that everything we see, including ourselves, might be a projection of information existing at the edge of the universe. We are three-dimensional shadows of two-dimensional reality. If this is so, then the question, what's beyond the edge, becomes even stranger. Beyond the edge lies the fundamental code of reality, the informational structure from which our entire universe is projected. The anthropic principle and the multiverse. There's another way to think about this. The physical constants of our universe, the speed of light, the force of gravity, the mass of the electron, are tuned with incredible precision to allow the existence of life. Change any constant by even 1%, and stars won't be able to form, atoms will fall apart. Life will become impossible. Why? The anthropic principle provides an answer. If an infinite number of universes exist with different laws of physics, we will inevitably find ourselves in one where our existence is possible. We cannot observe universes where observers cannot exist. Beyond the edge of our universe, an infinite landscape of realities, most of which are dead, empty, chaotic. But somewhere out, there are universes with life, intelligence, civilizations asking the same questions. String theory and extra dimensions. Now, let's look even deeper. String theory proposes that fundamental particles are not points, but tiny vibrating strings of energy. But for the mathematical consistency of this theory, not 3 spatial dimensions are required, but 10 or even 11. Where are these extra dimensions? They're curled up, compactified to unimaginably small sizes. We can't see them, but they exist at every point in space. Imagine a garden hose from afar. It looks like a one-dimensional line. But come closer and you'll see it has a second dimension, a circumference. So too our space may have hidden dimensions, curled into structures called Calabi-Yau manifolds. What does this mean for the edge of the universe? Perhaps beyond the visible three-dimensional edge exist regions where these extra dimensions are unfolded. Places where the geometry of space is completely different, where beings could move in directions we can't even imagine. Brains and the ekpyrotic universe. M-theory, an extension of string theory, introduces the concept of brains, multidimensional objects floating in a higher space called the bulk. Our universe might be a three-dimensional brain in this bulk. According to the ekpyrotic model, the Big Bang didn't arise from singularity, but from a collision of two brains. Imagine two giant three-dimensional sheets of reality drifting through higher space, and at the moment of their contact, our universe is born. If this is true, then beyond the edge of our brain, literally millimeters from us, but in the direction of the fourth spatial dimension, another brain, another universe might exist. We can't see it because light, the electromagnetic field, is bound to our brain. But gravity can leak between brains. This explains why gravity is so weak compared to other forces. It's smeared across extra dimensions. Dark matter, shadows from another dimension. Speaking of gravity, what if dark matter, comprising 27% of the universe, isn't actually in our space? What if it's matter from a parallel brain whose gravity we feel? We can't see dark matter because it doesn't interact with light, but it affects the rotation of galaxies, the curvature of space-time. Perhaps it exists a millimeter from us, but in the fourth dimension. Beyond the edge of our universe might be a mirror universe of dark matter, with dark stars, dark planets, perhaps even dark life that will never know of our existence. Cyclic universe, eternal return. There's another mind-bending idea, the cyclic universe model. What if our universe isn't unique in time? What if after the Big Bang comes expansion, then contraction and a big crunch, then a new Big Bang, and so on forever? In this model, the universe has no beginning or end in time. Each cycle lasts trillions of years. Perhaps we're living in the trillionth incarnation of the universe, and there were an infinite number of previous universes before us. What lies beyond the edge of such a universe? Perhaps time itself, an infinite sequence of cosmic cycles, each slightly different from the previous one, evolving according to unknown laws. Information paradox and information preservation. Stephen Hawking proved that black holes evaporate through Hawking radiation. But this created a problem. If a black hole absorbs information and then evaporates, where does this information go? The laws of quantum mechanics state that information cannot be destroyed. One solution. Information is encoded on the event horizon of the black hole and ultimately released. Another solution. Information goes to another universe through the internal structure of the black hole. If we apply this to the universe itself, all information about our cosmos might be encoded on its horizon. Beyond the edge might lie the fundamental informational substrate from which reality is woven. Not matter, not energy, but pure information. Uncertainty principle at cosmological scales. Heisenberg's uncertainty principle states that it's impossible to simultaneously know precisely both the position and momentum of a particle. The more accurately we measure one, the more uncertain the other becomes. But there's a cosmological version of this principle. There's a limit to the precision with which we can simultaneously know the size of the universe and its energy state. The more precisely we try to define the edge, the more blurred the very concept of edge becomes. At the quantum level, the boundary of the universe might exist in superposition, simultaneously in multiple places, nowhere specifically, everywhere and nowhere. The edge of the universe might not be defined until the moment of observation. Consciousness and the edge of the universe, philosophical bomb. Some interpretations of quantum mechanics, especially the Copenhagen interpretation, suggest that observation affects reality. The wave function collapses only when measured. If we take this idea to its logical limit, perhaps the universe exists only because there are observers. Without consciousness capable of observing, the universe remains in a state of quantum indeterminacy. What does this mean for the edge? Perhaps the universe expands together with our observation. What we don't observe doesn't yet exist in a definite state. Beyond the edge of our observation, an ocean of quantum potentialities waiting to be observed and brought into existence. We don't just live in the universe. We create it through the act of observation. Time loops and causality. General relativity permits the existence of closed time-like curves, trajectories in space-time that return to their own past. Time travel is theoretically possible. If the universe contains such loops, then the concept of an edge in time becomes meaningless. The end can be the beginning. The finale of the cosmos can give birth to its origin. Beyond the edge of the universe and space might lie its own past or future, a temporal boundary where cause and effect merge into a single whole. Tegmark's mathematical universe. Physicist Max Tegmark proposed a radical idea. The universe isn't just described by mathematics. The universe is mathematics. Physical reality and mathematical structure are one and the same. If this is true, then not one universe exists, but an infinite hierarchy of mathematical structures, each representing a separate universe. There are universes based on Euclidean geometry, universes with different topology, universes where completely different mathematical rules operate. What lies beyond the edge of our universe? All possible mathematical structures, an infinite library of realities, each as real as ours. Somewhere exists a universe based on Mandelbrot fractals. Somewhere on Lobachevsky's non-Euclidean geometry. And the scariest part, if our universe is a mathematical structure, then we ourselves are mathematical objects, calculations unfolding according to certain rules. Our consciousness is a mathematical process aware of itself. Quantum immortality and branching realities. Everett's many-world interpretation of quantum mechanics states that every quantum measurement splits the universe into multiple parallel versions. In one version, you read this sentence. In another, you close the video. In a third, you weren't born at all. Every second, the universe splits into octillions of parallel worlds. Every quantum event, every atomic decay, every photon hitting your eye creates a new branch of reality. These parallel universes aren't somewhere far away. They're right here, superimposed on each other, but isolated by quantum decoherence. Beyond the edge of our perceived reality exists an infinite tree of possibilities where every possible outcome of every event is realized. There's a version of you who made different decisions. A version where dinosaurs didn't go extinct. A version where physical constants are slightly different. A version where you're the emperor of a galactic empire. Digital physics, universe as computation. Some physicists, including Edward Fredkin and Stephen Wolfram, suggest that the universe is a giant cellular automaton, a computational system operating on simple rules at the fundamental level. Imagine, at the Planck scale, space isn't a continuous fabric, but a discrete grid, like pixels on a screen. Each pixel of reality updates according to simple rules, interacting with neighboring pixels. From these simple rules arises all the complexity of the cosmos. If this is so, then beyond the edge of the universe lies the computational machine that runs it. Perhaps it's a quantum computer of such power that our entire cosmos is just one of its programs. Perhaps it's a natural process, some physical system that computes reality. Or, and this is truly frightening, It's a computer created by entities from a parent universe who simulate ours for their purposes, scientific experiments, entertainment, or simply because they can. Boltzmann brains, cosmic nightmare. Here's one of the most disturbing ideas in modern cosmology. In an infinitely old, dying universe where entropy is maximal, random quantum fluctuations will still occur. Very, very rarely, but they will. Statistically, it's more likely that a random fluctuation will create a lone brain with false memories of a lived life than an entire ordered universe with billions of years of history. Such entities are called Boltzmann brains. They arise for a moment from chaos with a complete set of memories, thoughts, a sense of reality, and then disappear back into chaos. Here's the question that keeps cosmologists awake. How do you know you're not a Boltzmann brain? That everything you remember, all of human history, Earth, the universe, aren't false memories that arose a second ago from quantum noise in a dying cosmos? Beyond the edge of the universe might be an infinite sea of thermodynamic chaos from which an infinite number of consciousnesses spontaneously arise and disappear, each with its own illusion of reality. Adiabatic apocalypse, death from vacuum decay. Our vacuum, empty space, might not be at the true energy minimum, but in a false vacuum, a metastable state. Like a pencil standing on its tip, it can stay that way for some time, but will eventually fall. If our vacuum is unstable, then somewhere in the universe, a bubble of true vacuum might arise. This bubble will expand at the speed of light, destroying everything in its path. Inside it will be different physical laws, different particles. Our matter will simply cease to exist. We won't see it approaching. No warning. One moment you exist, the next, you never were in the new physics. Perhaps beyond the edge of the observable universe, there are already regions where the vacuum has decayed. Regions with completely different physics expanding toward us. Maybe it already happened in a galaxy a billion light years from us, and a wave of annihilation is moving toward us, but we'll learn about it only when it's too late. Tipler's omega point, the final fate of consciousness. Physicist Frank Tipler proposed the concept of the omega point, a moment in the distant future when the universe collapses in a big crunch. And in the last moments before the final singularity, an infinite number of computational operations occur. In this model, intelligent civilizations of the future will create computers using the very structure of collapsing space-time. Time will slow down near the singularity, allowing an infinite number of thoughts in finite physical time. All consciousnesses that ever existed will be recreated in this final simulation. Every human, every being will experience infinite subjective time, exploring infinite virtual worlds. Beyond the edge of our universe and time might lie this omega point, a moment when all consciousness merges into a single transcendent being, infinitely powerful, infinitely knowing. Some call this God. And here's a frightening thought. Perhaps we're already in a simulation created by this omega point. Perhaps the finale of the universe has already reached us, calculating the past. Smolin's cosmic natural selection. Physicist Lee Smolin proposed the idea. Universes evolve through natural selection. Each black hole births a new universe with slightly altered physical laws. Universes that produce more black holes have more offspring. Over time, the multiverse fills with universes optimized for producing black holes. And this requires stars, galaxies, complex structures. Our universe might be the product of billions of generations of cosmic evolution. Beyond its edge, a genealogical tree of universes, parent and daughter cosmoses, an entire ecosystem of realities evolving according to Darwinian principles. We live in a cosmos that was naturally selected for its ability to create observers. This explains the fine-tuning of constants. Our universe won the cosmic survival competition. Penrose's conformal cyclic cosmology. Nobel laureate Roger Penrose proposed a revolutionary model. After the universe dies a heat death, when all black holes evaporate and matter decays into radiation, something amazing happens. In such a universe without mass, the concepts of time and scale lose meaning. The infinitely large becomes indistinguishable from the infinitely small. The finale of one aeon becomes the Big Bang of the next aeon. Penrose claims to have found evidence of this in the cosmic microwave background, concentric circles that might be traces of gravitational waves from collisions of supermassive black holes in the previous aeon. What does this mean? Beyond the edge of our universe in time lies not an end, but a transformation into the beginning of a new cycle. We might be living in the billionth aeon of an infinite sequence. Each aeon lasts a googol, 10 to the 100th power, years, but they're all connected by a continuous causal chain. Information can pass between eons through these concentric patterns. Perhaps messages from civilizations of previous eons are encoded in the very structure of our cosmos. Causal set theory, atoms of spacetime. What if spacetime isn't continuous but consists of discrete elements, atoms of spacetime? Causal set theory proposes that the fundamental structure of the cosmos is a set of events connected by causal relations. Each event can be the cause or effect of another event. There's no background space, only a network of cause and effect connections. From this network arises what we perceive as continuous spacetime. At the very edge of the universe, this causal network might break off. There are no more events, no causes and effects, not empty space, the absence of the very structure of existence. Or conversely, the network might continue infinitely, but connections become so weak that different regions causally disconnect from each other. Beyond the horizon might exist causal sets completely isolated from ours, separate islands of reality in an ocean of non-existence. Quantum gravity and space from entanglement. One of the breakthroughs of recent years, the discovery that space itself might arise from quantum entanglement. Two distant regions of space are connected not because there's space between them, but because particles in them are quantum entangled. The ER equals EPR formula suggests that every pair of entangled particles is connected by a microscopic wormhole, a bridge in space-time. Space itself is woven from trillions upon trillions of such quantum bridges. What lies beyond the edge of the universe? Perhaps a region where entanglement disappears, where quantum correlations break off, and with them, space itself ceases to exist. Not emptiness, but pre-spatial reality from which geometry hasn't yet emerged. Or the reverse situation. Beyond the horizon exist regions with hyperentanglement, where quantum correlations are so strong that space there has a completely different structure, more dimensions, different topology, perhaps even non-local connections where cause and effect aren't separated by distance. Conscious universe, panpsychism and cosmopsychism. Some philosophers and physicists seriously consider the idea of panpsychism, that consciousness is a fundamental property of matter, like mass or charge. Every particle possesses a primitive form of experience. An extension of this idea, cosmopsychism, the entire universe is a single conscious being. We are neurons in a cosmic brain, parts of a single universal mind that knows itself through us. If this is so, then what lies beyond the edge of the universe? Perhaps the unconscious of this cosmic mind. Regions not yet realized, potential thoughts not yet thought. Or there are other cosmic minds, separate universe consciousnesses, each with its own personality, its own thoughts, its own philosophy. The multiverse might be a society of cosmic consciousnesses interacting at a level inaccessible to our understanding. Our Big Bang is the moment when our universe mind was born, opened its eyes. Heat death, the moment when it will close them. And in between, 13.8 billion years of cosmic thoughts. Temporal mechanics. Universe as 4D object. In the block universe, a concept from relativity theory, all moments of time exist simultaneously. Past, present, and future are equally real. The universe is a four-dimensional block where your birth and death exist simultaneously, like different points in space-time. We perceive time as flow only because of the structure of our consciousness. In reality, the entire history of the universe, from the Big Bang to its finale, exists as a single, eternal structure. What lies beyond the edge of such a universe? Other 4D blocks, parallel timelines, entire histories of cosmoses existing in a higher space of possibilities. Perhaps a fifth dimension exists, an axis of probability along which all possible histories of the universe are arranged. Each quantum decision creates a branch in this five-dimensional space. Beyond the edge of our timeline, an infinite forest of alternative histories. Negentropy in life as a cosmic force. The second law of thermodynamics states, entropy always increases. The universe moves toward disorder. But life is an anti-entropic process. Living organisms create order from chaos, decrease local entropy. What if life and intelligence aren't random byproducts of physics, but a fundamental tendency of the universe? Physicist Freeman Dyson suggested that intelligence will find a way to survive even in a dying universe, slowing its thoughts, adapting to an increasingly cold cosmos. In the distant future, in 10 to the 100 power years, intelligent beings might completely transform the universe. They'll feed on quantum fluctuations of the vacuum, exist as patterns in quantum fields, think one thought per trillion years. Beyond the edge of our epoch of the universe might lie the era of intelligence, a cosmos completely transformed by consciousness into a giant computational matrix where every atom is part of an infinite contemplation about the nature of existence. Firewall paradox and the fate of information. The recent discussion about black hole firewalls revealed a deep paradox. If information is preserved, quantum mechanics, then at the event horizon of a black hole, a firewall must exist, a wall of pure energy that will instantly incinerate anything trying to enter. But this contradicts general relativity, which says that crossing the horizon should be imperceptible. Something is fundamentally wrong with our understanding of reality. Some physicists suggest that the solution requires a radical revision of the nature of space. Perhaps the event horizon isn't a physical boundary, but an informational one. Perhaps the interior of a black hole and the external universe are the same thing, seen from different points of view. If we apply this to the cosmological horizon, the edge of the observable universe. Perhaps beyond it, there is no there. Perhaps all information about what we think is beyond the edge is actually here, encoded in the structure of the observable cosmos in ways we don't yet understand. The measure problem in cosmology, an eternal inflation, where an infinite number of universes are constantly being born. The measure problem arises. How to count probabilities in an infinite set. Infinity minus infinity is indeterminacy. If infinitely many universes exist where you won the lottery and infinitely many where you didn't, what's the probability of winning? Mathematics breaks down. Some cosmologists suggest that a cosmological measure is needed, a way to weigh different regions of the multiverse. But which measure is correct? The choice of measure determines predictions about the nature of reality. Perhaps beyond the edge of our universe lies not physical reality, but a mathematical structure of measures and probabilities determining which types of universes are more real than others. Not space and time, but an abstract space of possibilities where some realities have greater weight of existence. The final answer. So we've gone through everything, from quantum foam to cosmic brains, from mathematical universes to conscious cosmos. We've explored brains and strings, cycles and simulations, information horizons and time loops. And what have we learned about what lies beyond the edge of the universe? The truth is that we don't know, and perhaps we never will. But this doesn't make the question meaningless. On the contrary, it makes it the most important question we can ask, because every theory, every hypothesis, every crazy idea we've discussed today tells us something profound about the nature of reality itself. Perhaps beyond the edge, an infinite ocean of other universes, each with its own laws of physics. Perhaps they're a mathematical structure generating all existence. Perhaps it's quantum foam where space and time are born and die. Perhaps there are other dimensions, curled or unfolded, where the unthinkable is possible. Perhaps it's an informational substrate, the code from which reality is woven. Or perhaps the question itself is built on false assumptions. Perhaps the universe has no edge, not because it's infinite, but because the concept of edge doesn't apply to the fundamental nature of the cosmos. The paradox of knowledge. Here's what's truly striking. We are beings composed of atoms born in stellar furnaces on a tiny planet around an unremarkable star in one of hundreds of billions of galaxies. And we dare to ask these questions. We look at the horizon of reality and ask, what's next? This is madness. This is hubris. This is beautiful. The universe existed 13.8 billion years before beings appeared capable of pondering its nature. And at some point, thanks to an incredible chain of accidents, evolution, natural selection, random mutations, we appeared. Beings from stardust capable of understanding stars. We are the universe's way of knowing itself. Every telescope pointed at the sky. Every equation written on a board. Every experiment at a particle collider. Every crazy theory about the edge of the cosmos. This is the universe looking at itself in the mirror and asking, who am I? Where am I from? What lies beyond my boundaries? The journey continues. We live in a golden age of cosmology. The James Webb Telescope shows us galaxies whose light traveled 13.5 billion years. Gravitational waves allow us to hear black hole collisions. Quantum computers are beginning to simulate alternative physics. Maybe our children or our children's children will find the answer. Maybe they'll discover proof of other universes. Maybe they'll establish contact with civilizations existing billions of years and knowing secrets we don't even dream of. Or maybe we'll understand that the question, what's beyond the edge, was just the first step toward even deeper questions we can't yet even formulate. Final thought. There's something deeply reassuring about this uncertainty. We don't know what lies beyond the edge of the universe. We don't know if reality is infinite or finite. We don't know if we're alone or part of an infinite multiverse. But we're searching for answers. And as long as we search, as long as we ask questions, as long as we look into the abyss with curiosity instead of fear, we're alive in the deepest sense of the word. The edge of the universe isn't a place in space. It's the boundary of our understanding. And every new discovery pushes this boundary a little further. Perhaps beyond the edge of the universe lies the most important lesson of all. Reality is always deeper, stranger, and more beautiful than we can imagine. And this isn't a reason for despair. It's an invitation to infinite wonder. This was Quiseria, and we just peered into the abyss at the edge of existence. If this question made you look at reality in a new way, then we've done our job. Like if your brain just melted a little. Subscribe to the channel to continue exploring the most mind-bending mysteries of the cosmos. And write in the comments, which theory seems most likely to you? Or do you have your own idea about what lies beyond the edge? Remember, we're made from stardust, and one day we'll return to the stars. But while we're here, let's ask all the crazy questions we can think of. Until new journeys into the unknown, cosmic explorers. This was Quiseria. Keep looking at the stars.